differential scattering calorimetric graph, okay, in which the uh, three forms of the same substance are given. One is the anhydrous form, suppose it may be XYZ substance. The anhydrous form shows the one sharp peak. Then anhydrous and hydrous ratio, that is the 10 part anhydrous and 1 part of dihydrate, if it is a mix, okay, it gives one sharp peak with the a small peak, okay, small initial peak and another second sharp peak, and full dihydrate form. Here there is a pure dihydrate, no anhydrous is mixed. It shows the one peak and after that a second peak. This is the graphical presentation. Okay, it is clear that whether it is a pure anhydrous form or it is a pure dihydrate or whether it is a mixture of anhydrous or dihydrate form. So from these graphs, okay, the interpretation can be done. Okay, if you are having the skilled or you can interpret that graphs properly, you can identify whether your drug get converted from anhydrous to dihydrate or hydrous to anhydrous, okay, during the mixing with the other excipient. Okay, so it can be identified. Above graph is there is a thermogravimetric analysis. Gravimetric indicate uh, the principle of gravimetric is somewhat different. Okay, it measures the changes in the sample weight. In thermogravimetric analysis, what happens? It measures the changes in the sample weight as a function of time or temperature. When there is a gravimetry, there is a relationship with the weight. Okay, so here weight gain or loss is measured, and in case of the DSC and DTA, heat loss or gain is measured. Okay, in DSC or DTA, heat loss or gain that is measured, and in TGA, weight loss or weight gain of a sample that is measured. Okay, so when we are talking about this, 1 minute. Yes, slides are visible now.
Yes, sir.
Yes, sir.
So DTA and DSC, okay, both are having the same principle. DTA or DSC का principle same है. Okay, TGA, that is thermogravimetric analysis, having the somewhat different principle. What are the applications of this thermal analysis? To determine the melting point, heat capacity, heat of fusion, then assessment of various crystal form. Okay, various crystal form, cubic, hexagonal, tetragonal, you can identify. It can be used during salt form screening. It investigate the polymorphic transition, whether the one polymorph get converted into the another polymorph. It elucidate stability relationship between the polymorphs. Okay, it detect the presence of hydrates or solvates. Okay, then it detect the decomposition, and it also used to determine the stability with respect to its physical changes. Okay, so there are different application of DSC and DTA. Okay, these are the very useful methods and having the lot of applications in the pharmacy or any other field also. It is not only applicable to the pharmacy. Okay, so these are the very useful method to identify the not only drug excipient compatibility study, but rather all different types of parameters can be studied by these two methods. Okay, but we are seeing these two methods from the point of view of drug excipient compatibility study here. Okay, so today we will stop here. Okay, because I have some other urgent work. We will cover the rest of the portion in the next lecture. Okay, so hereby I am stop my sharing. Okay, and if you have any query you may ask immediately, otherwise you may leave the meet. Yes, anybody is having any question, otherwise you may leave the meet.